Welcome to Cadence Design Systems Omnis Tutorial Tuesday, where we show you how to use our fully integrated environment Omnis in short videos of a few minutes. In this video, I'll show you how to mesh Turbomachinery Meridional effects like seal leakages, bleeds, or cavities. We start from a previously linked seal leakage geometry, which is the subject of another video. In the mesh context, an Omnis AutoGrid mesh setup named Mesh Setup for Turbo Configuration is automatically created. The channel is ready to be meshed using the row wizard or manual settings. Check the dedicated video covering automatically structured mesh generation for turbomachinery applications for more details. Click on the Meridional view and select the ZR Effect 1 in the family tree. Set the view to full screen for better visualization. If needed, adapt the cell width at the wall in the Meridional property panel. Note that the first cell size needs to be at least as large as the channel first cell size. Click on Automatic Blocking. A 2D block topology is automatically created for the ZR effect in the Meridional view. Click on the Default Mesh button to automatically set up the number of points and clustering respecting the imposed first cell size, the default mesh properties, and the number of grid levels. Impose 200 optimization steps to smooth the Meridional mesh and click on the Optimize Mesh button to apply the imposed optimization steps on the default mesh. The Meridional view shows the final 2D mesh of the ZR effect. Lastly, save your Omnis project and launch the 3D mesh generation. The final 3D mesh is displayed in the 3D view. Note the presence of two full non-matching connections between the seal leakage and the channel. In addition, a periodic matching connection is imposed between the ZR domains. Use the Show Mesh Quality button in the PI, switch from the Hex Press to the AutoGrid tab, and check the mesh statistics for each ZR effect. Here, a very good structure mesh with approximately 2.15 million points was generated in 19 seconds on two processors. The ZR Effect 1 has 538,000 points, and the ZR Effect 2 has 443,000 points. Both domains show excellent minimum orthogonality, maximum aspect ratio, and maximum expansion ratio. As we've just discussed, by default, Omnis AutoGrid connects the ZR effect to the channel using full non-matching connections. Fully matching connections can be attained by clicking on the Add Matching Z Constant Lines button on the ZR Effect Meridional panel. Z constant lines are added to the channel at the vertex of each 2D block connecting to the passage. Z constant lines can be edited by expanding the Z constant lines folder in the tree, selecting the desired curve and either having their control points moved in the Meridional view or their shape defined in the property panel. Unnecessary Z constant lines, for example, the two previously existing ones, can also be deleted. Select row 1 and regenerate the blade-to-blade view. Note that the Z constant lines used for the matching connections do have an impact on the blade-to-blade mesh. Go to the 3D tab and select the Periodic FNMB at Rotastator Interface option to impose a full non-matching connection at the rotastator connection. This option is recommended for better mesh quality. Launch again the 3D mesh generation. The final 3D mesh is displayed in the 3D view. Note that the seal leakage and the channel have matching connections. On the other hand, the connection between the ZR domains is now of the type fully non-matching, which prevents skewed cells. Use the Show Mesh Quality button in the PI, switch from the Hex Press to the AutoGrid tab, and check the mesh statistics for each ZR effect. Here, a very good structure mesh with approximately 2.8 million points was generated in 20 seconds on two processors. The ZR Effect 1 has 574,000 points, and the ZR Effect 2 has 864,000 points. Both domains show excellent minimum orthogonality, maximum aspect ratio, and maximum expansion ratio. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming content like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.